Okay.
And then draw the other one. It's totally up to you. It just depends if you're a visual person or you need to see it like this. What is the formula for a triangle if you can tell me?
Isn't it length times height
So
divided by 2?
they're both base times height, but the triangle you divide by 2.
Oh, okay.
So we're essentially adding these together.
Oh.
So base times height is
20 meters square?
Say that one more time.
20 meters square?
You're multiplying the top numbers, base times the height. Then you're dividing by 2.
Divided by 2 is 50.
That's right.
Meters square. The other one is 20 meters square.
You're multiplying 10 times 10. You've added a couple of times. Yes.
So 150 meters squared.
Yes. Yes. Very good. All right. Let's look at lower left here.
Okay.
Again, they're showing you where the cut is. You may not get that on a test or a quiz.
Oh, she usually does that, even if it's on tests or quizzes.
Well, that is nice. I do encourage you to redraw them with the dimensions. So go ahead and try this one on your own and let me know what you come up with.
26 meters square.
Say that one more time.
26 meters square.
You've got to find the area of each of these individually. What is the area of this top one?
The top one is 13 meters square.
It's base times height. So base times height, you're multiplying.
Oh my God, I'm adding. I need
yes.
to 30.
30. So the first one, and you can even put the area inside. That's another thing that students will do.
8 times 5 is, so then that is 90 meters squared.
Try again. 5 times 8. 5 times 8
is 40.
40 meters squared. Okay, so you're going to add those together. 30 plus 40
is 70.
70 meters squared.
Okay.
All right. So last composite on this page. Okay.
And this one looks more challenging than the other one.
It kind of is. I mean, there's three triangles, but you actually only want to draw this top one. Okay, because it has a base of 12. And then what is the height? What is that? Do you see where that's pointing to the height?
5.
It's 5. So it's
12 times 5.
Divided by 2. It's base times height divided by 2.
So that's divided by 30. 30 meters squared.
That's right. And then the base is 4 times 12.
And that is 40, 56, 58.
48.
48. Okay.
48. Might be good to do some quick, rocket math or multiplication tables or something to get
because I haven't been focusing on the division. I've been focusing on the division of rocket math, not the multiplication.
So we're going to add these together. 30 plus 48
is 78.
78 meters squared. Any questions on that before we move on to the next page?
No.
Okay. So you're classifying triangles by angle. Okay, so
the number 2s are right angle.
Yeah, so you actually start with number, like you want to first look down the page and let me just kind of this I don't know, snip this in this way. if they've got a right angle, they're a right triangle. That's the easiest way to do it. So
Oh, so if they've got a square in them, then they're right.
exactly. Right. So which of these, I guess it's 1, 2, 3, 4, 5, 6, 7, and 8. Which of these are right triangles?
Number 4 is a right triangle. Number 2 is a right triangle, and number 7 is a right triangle.
Good. Okay. All right. So now the next, the obtuse, I think, is the next easiest to sort of see. If this is 90, then obtuse is where it just kind of goes a little bit past 90.
More than 90, and then obtuse less than 90.
Yes, but I think in terms of your order here, you might see obtuse faster. Can you tell me which of these are obtuse?
3.
Okay.
5.
5, good.
And 8.
8, yeah. It would be good if you could cut these out and like see them, rotate them to see the obtuse. If this, oh, you actually have this on paper, don't you? So I would rotate the paper until you could see that obtuse angle. And then by by the fact that these are the only ones left, the other ones must be acute. 1, 2, 3, 4, 5, 6, 7. Yeah.
So I guess the only acute one is 6 and
1. Yeah.
1.
Yep. Good. Okay. For fractions as part of objects. I see. Okay. You do something like this actually in chemistry. Sometimes I think students don't realize how much this early stuff matters when they take other courses. So I snipped in questions 1 and 2. 1, you can think of the top number as being how many that are shaded, number shaded, and the bottom is the total squares.
Okay.
So obviously there's 1 shaded, that's why there's a 1, but there's 1.
And then there's 4 squares total.
Right.
But one of them is shaded. So then number 2, there's 5 squares total, and 4 of them are shaded.
That's right. And you almost want to do it as shaded first, then.
Okay, so then you'd say, well, this is a whole, the next one. So you could do 5 over 5, or you could just do 1, I guess.
You could do 1 whole on that. Let me just get to where I can snip a few of these in.
And then 4, I guess trying to look different, but still there are 6, and so 2 shaded, and there's 6.
Okay, so that's 2 out of 6. Now, I think you need to reduce the
No, that's 4 out of
fractions.
5. Oh no, sorry. I was confused.
How about number 5?
Number 5, 2 out of 3, so
Okay.
2 over 2 thirds, I guess.
Good. Just give me your answers as you go here. I'll check.
5 thirds.
For which one?
Or sorry, 3/5. 3/5 for number 6.
All right.
3/4.
Okay, good.
3/7.
Good.
5/6.
Okay, good.
3/5.
Good.
2/4.
Okay.
4/5. 4/6. 5 8. 7/8. 2/8. 1/6. 4/7.
Good.
5/7.
Good.
And 2/6.
Good. So I circled a couple here that you can reduce. And maybe ask your teacher if you need to do that before you turn it in.
Okay.
We can reduce them, but let's make sure we hit everything. Oh, this is
and I already did the primes.
great. Let me just check your work here. 2, 3. Wow, it's a weird order. Why aren't they in order? It's not right.
Well, they are in order.
Well, I was thinking the numbers they would just give you like in this increasing order, like 2, 3, 4, 5, 6, 7, 8, but they mixed them up here.
No, those are the numbers to ask you if they're prime or not.
Yeah. So
Numbers-
everything looks good on that page there. So that's really good. So do you have any old assignments that we need to go back and correct? I know sometimes that's
No, but I guess we could reduce the fractions part.
yeah. Go ahead and reduce. I circled them here. Those ones that I circled, you can reduce. I'm gonna go back and look at your previous assignment because I think we were rushed to some
And
extent.
I finished that one.
Oh, good.
So yeah. Can you reduce this down to 1/4?
That's a 2/6. The first one, or 2 divided by
Oh.
6.
I was doing number 16.
Oh, number 16. Yes, that is 1/4. Good.
But then for number 2, you could get 1/3.
That's right.
Number 11, you can get 1/2. So 1/2.
That's right.
For number 12, no, for number 13, you can get 1/3.
We're looking at 4/6.
Yeah,
How did you get 1/3?
because you can divide 4 by, so you can divide, actually, wait, never mind, sorry. It would be 2/3.
2/3. Good. Like that. And then that last one, number 20, 2/6.
1/3.
Good. Okay, so now you don't have to ask. You just have those down. Okay, so here's some fractions to compare here. Let's go I don't know, 5/7 and 21 over. Actually, I shouldn't make that too large. Let's go 4/6. So this is the, this symbol, this symbol, this symbol.
Okay, so I guess it'd be 5/7 is larger than.
How do you know that without doing something here?
Because the denominator is larger.
You have
and
to
the
make
numerator is larger, I guess. I don't know.
you want to make a common denominator here.
Okay.
So you're gonna use this 6 on the right and multiply the top and bottom by 6. And then this 7 on the left and multiply the top and bottom on the right.
Okay.
You cannot do it where you sort of just feel like, oh, I think that feels about
Okay.
right.
So 5 times 6 is 30. 7 times 4 is so yeah, I guess I would be right, even though
What are
since I
your
did it.
what
5
are your
7
fractions?
is larger.
So which of these symbols, A, B, or C?
A.
Yes. Okay. Yeah, and you really want to show, hopefully you showed that it was 30 over 42 and this was 28 over 42. And yeah, it's the same. Okay. So here's another one. Let's say it's 0.56 and 5/9.
Okay.
There are a couple of ways to do this. I'm not sure if you've seen this yet, but tell me what you're doing or what you're thinking on this one.
Well, you could change that decimal into a fraction, or you could change that fraction into a decimal.
That's right. Which do you feel like is easier for you?
Probably, I don't know. Probably
So here,
change the
so
decimal
let
into
me
a
talk you through it a little
fraction.
bit. If you change this to a fraction, you're going to have to make a common denominator. Okay. But if you change this to a decimal, you can just compare. So I would tell you to
Probably
turn
just
this into,
change it to decimal.
yes. Okay, so you're going to have to do that long division here.
So
Let me know if you have any questions on that division.
55.55, and then it's repeating.
Yes, so it's 0.55 repeating. How does that compare to 0.56?
5/6 would be technically a little larger.
That's right. Very good. Let's have you try another one here. So go ahead and try this one. I would again recommend making it into a decimal.
Mhm. Yet again, it's 5 repeating.
Not this one.
No, wait, hang on. Okay. 6/11 is larger.
What's your decimal for 6/11?
5 point. I think that's wrong actually though, because that it wouldn't be a whole number.
I'm yeah, these are really carefully chosen by me to be very difficult. Um,
Oh, I put the decimal on the wrong side. That makes sense now.
Did you get
I
point?
had 0.54.
Yeah, so it's just slightly smaller.
Sure, I had 5.4.
Okay, yeah, and that would obviously be very much larger. So, okay, so probably a good place for us to stop here.